My name is Mark Green, and I'm an oceanographer and oyster grower. I'm a professor at St. Joseph's College. There's no debate about ocean acidification. It's real, and it's happening very, very quickly. And I think probably one of the biggest concerns, literally, is the crash of a great many global fish stocks. We don't know what's going to happen, and we really have no way to experiment on broad level, experiment to try to determine the broad level ecosystem changes that are going to happen. But they are going to happen, and they're going to be severe, because you can't remove major components of an ecosystem and not expect, severe changes to occur. Since the start of the Industrial Revolution, we've been putting a lot of carbon dioxide up in the atmosphere through the combustion of fossil fuels principally, as well as cement mixing and deforestation. And we've increased atmospheric CO2 from about 280 parts per million prior to the Industrial Revolution to about 390 parts per million today. So what's happening is, as we're increasing the CO2 in the atmosphere, that CO2 is being dissolved into the surface layer of the ocean. And in the last 100 years, we've dropped the pH of the ocean from about 0.1 pH units. Now, pH, that doesn't sound like a lot, and people kind of roll their eyes when they hear that, but pH is based on a log scale. Log scales take a range of large numbers and compress them into small ones. So a 0.1 decrease in pH, which we've seen, corresponds to a 30% increase in acid. The CO2 goes into the water, it reacts with water and produces a weak acid called carbonic acid. And that essentially is ocean acidification in a nutshell. My work is focused mostly on small larval and juvenile sized bivalves. They're commercially very important. Casco Bay alone is a $21–22 million a year fishery just for the soft shell clam. When a larval clam, and these guys are small, they're 100 microns, 150 microns, when they're exposed to these acids, to ocean acidification, you can see within a 24-hour period, you can see visual evidence on the outside of their shell. It begins with some pitting, essentially, of the shell. By 72 hours, you can see that the dissolution has corroded their entire shell. So in a time series photograph for larval clams, you can see within a 2–3 day period almost the complete destruction of their shell. So by looking at the small ones, you're looking at the most vulnerable, most soluble of the size classes, and it helps us to predict, pretty clearly what's going to happen in the future, and the consequences aren't good. Ocean acidification has only been on people's radar really for about 5 years, but in that 5 years' time, we've learned a tremendous amount. It's just simple acid-based chemistry. You put CO2 in water, you create acid. To put it in perspective, this boat, my boat here, Goose, weighs about a metric ton, minus the engine. Imagine if we, imagine dumping 21 million of those in the ocean each and every day. That's a substantial amount of carbon, and that is what we're doing. And we're just putting so much in, we're changing the chemistry. The ocean can't keep up with the amount of acid that we're putting in. We can't let the perfect be the enemy of the good when it comes to finding a solution. There's no silver bullet, there's no perfect solution, but there are plenty of solutions. We just have to have the political gumption and desire to do something about it, and that's to switch to a low carbon form of energy generation. It's not an all or none type scenario, right? I'm not talking about giving up our homes, going back and living in caves. There's what's called stabilization wedges, where, for example, if we increased in fuel efficiency of cars in the United States, we would drop emissions, X%. If we insulated our homes, we would drop emissions X%. Limited deforestation of the tropics, which, by the way, we're deforesting at a rate of 59,000 square miles per year. We would decrease carbon emissions. Use more alternative energy in places where it's viable. Solar panels in the Southwest, for example. And when you start putting each of these in place, suddenly, you see, oh, emissions are down 10%, they're down 20%, they're down 30%, and that's what that's what we have to do. We're committed to some change. That's happened already. It's too late. We can't turn back. But we got to decide now how acidic we want the ocean. And small changes in emissions will translate to a slower rate of ocean acidification. We have the resources, we certainly have the technical resources and the scientific minds. We just need, at this point, we need people to step up to the plate and demand action by their congressional representatives with the full understanding that ocean acidification is a real issue with dire consequences if we don't do something. Our generation is going to suffer from this. My children are going to suffer from this issue, and obviously my children's children, but it's a here and a now issue, and we need to focus on it.